So for problem 13, we're given an experimental cart with a mass of 4.5 kilograms. So M equals 4.5 kg. And an acceleration given by the figure that it shows on the next page, which I went ahead and drew up there. So then it wants us to find the maximum net force on the cart and when this occurs. So the maximum force, so force max, is when M times A is the greatest. So the mass is constant, so it's going to be when acceleration is at the max. So acceleration is a flat line from 2 to 4, and that's the highest point, and it's at 10. So the maximum force happens at from 2 seconds to 4 seconds. So from when t is greater than or equal to 2 but less than or equal to 4. And so then you can calculate that out because in that time interval, the acceleration is 10. So you get the force max equals 4.5 times 10, which equals 45 newtons. So that's part A. And then for the second part, it wants you to find during what times is the net force on the cart constant. So then again, with this one, the net force is going to be constant when mass and acceleration are both constant. So mass is constant the entire time, and then acceleration, again, is only constant on this time interval. So it's going to be from 2 less than or equal to t less than or equal to 4 seconds. And then it asks us part C, when is the net force equal to 0? So again, since mass is constant, we're only looking at acceleration here. So we're trying to find when acceleration is equal to 0, because if acceleration is 0, then it doesn't matter what the mass is because the force is going to be 0. So on the graph, we only have 2 points here and here where the acceleration is 0. So that's at t equals 0